Good morning to all. In this session, we are going to discuss the orthogonality principle of signals. In the previous class, we already discussed the similarity between vectors and signals is orthogonality principle. Now just look at. Now let f1 of t is a signal. f1 of t is a signal. f2 of t is a signal. Now, one signal can be expressed in terms of another signal, just like vectors. In the vectors, we used VE. We used VE as error of vector. Here, the same concept we are using error signal. This is error signal of. E stands for error. So one signal can be expressed in terms of another signal, from some error will exist. Now, in this way, what is the error? Error is equal to f1 of t minus c times of f2 of t. Now, actually in any signals, error is to be minimized. That's why to get now upon some given time signal, upon some time interval, that interval is what? From t1 to t2. Signal means signal should contain time interval. Now, how to get this error? An average value equal to 2t2 minus t1 into integral t1 t2 of the error vector with respect to dt. For example, just look at 0.4 is the error. If you square it, 0.16. That means value is less than or not? Less than. That means what? If any error is there, if you get e square, definitely e square is less than e. So for this concept, taking the same concept into consideration, now here we are getting this value as 1 by t2 minus t1 into integral t1 t2 of this fe of t whole square to minimize this one. Once it is squared, what is f of e? f1 minus this is f of e. This value here we have to substitute. So in this place we are substituting f1 of t minus constant into f2 of t whole square dt. This is to reduce the error. Let the error be epsilon, like this, epsilon whole square. Now this can be in the form of a minus b whole square, a square plus b square minus 2ab. So here in this way we are going to get t2 minus t1 integral t1 t2, that will become f1 square. No need to write t always, directly I am writing f1 square plus c square f2 square minus 2c f1 f2 of dt. In calculus, you come to know that a function, to find a minimum value or maximum value of a function, dy by dx should be 0. Here this is error. To make the error a minimum value, we have to find dy by dx to 0. But here we have to differentiate the given formula, given equation with respect to c only. That means find d epsilon by the constant dc and make it to 0. Because to become a maximum or to find a maximum or minimum value, its value should be 0. Now just look at, we are differentiating with respect to c. That means only c, not t. With respect to c means what? The first term doesn't contain c value. Therefore, differentiating, this will become 0. This term we won't get. This term is having C terms. It is having C terms. Only 2 C terms will be representing. That means what? This value is equal to 1 by T2 minus T1 integral T1 to T2 differentiating C square 2C F2 square minus differentiating C is 1, power 1, differentiating numeric 1, its value equal to 2 F1 F2 dt equal to 0. dt equal to 0. Now, this constant 1 by T2 minus T1 is not equal to 0, constant. If taking that side, it will become 0. Only this part will be representing. Now just look at. Now just look at. What part is remaining? Integral T1 T2. Look at one more point. 2 is constant, 2 is constant. 2 also you can cancel. So remaining one is called what? C times F2 square dt minus, you take this integral to RHS, it will become minus, will become plus. This become T1 T2 of F1 F2 dt. Now just look at. No difficult steps. 1 by T2 minus T1 is a constant. Taking this to RHS side, this will become 0. 2 is constant, 2 is constant, you can cancel. Now this part minus is there. Taking that part, that side, this minus will become plus. You will get splitting, expanding the two integrals. Look at this one. Now, here C is constant, so just you can mention C outside the integral. Outside the integral. Now, what is C? What is C is equal to integral T1 T2 F1 F2 dt by taking this denominator, integral T1 T2 of F2 square dt. This constant you got. This is the minimum value. If C equal to 0, what happens? Cross multiplication. Then numerator value integral T1 T2 F1 F2 dt equal to 0. This is the principle. D1 D2 equal to 0. This is called, now just look at what we got here. 2 signals we considered. One can be expressed in terms of others. In this expression, there might be some error. That error. Now from this, that error equal to, taking this to this side, equation 1. Upon to find the error throughout the interval, signal means what? Width is there from T1 to T2. So overall, on average, error is 1 by T2 minus T1 integral. If E is the error, E square will be error less than E. That's why for that purpose we squared it. What we squared? Error. What the error representing in place of this? We are using this expression, make it this expression. Just expanding, it is of the form a minus b whole square, a square plus b square minus 2ab. Now, in the differential calculus, to find the minimum value of a function, dy by dx should be equal to 0. Taking that formula into consideration, here we are differentiating this constant. With respect to this constant we are differentiating. That's why all these denoted by epsilon. So differentiating epsilon with respect to the constant c and equal to 0. Then what will happen? We are not integrating with respect to t. We are integrating with respect to c. That's why it doesn't contain c terms. This entire term will become 0. C square will become 2c. F2 square constant. 2c will become 2. F1, F2 is constant. As per formula, equal to 0, equal to 0. This is constant, take to the side 0. 2t is constant, cancel it. Now here two integrals. This integral minus this one. Apply integral to each one, taking these two RHS. That is the step. Now here with the C is a constant. C multiplying with integral equal to that integral. Therefore, C equal to numerator by denominator. Now, if C equal to 0, what will happen? C equal to 0, cross multiplication, this into this equal to 0. Then what we get? Integral T1, T2, F1, F2 dt equal to 0. That is the final output in signals. This is the final output. Now just look at. Now we make the comparison. I think it is very much clear. I think no difficult steps are involved. Now just look at. V1, V2 are two vectors. V1 dot V2 equal to 0. We call it as orthogonality principle, orthogonal. This is orthogonal. This orthogonal with respect to which one? Vectors. Orthogonal with respect to vectors. Now come this side. Now just we are same principle we are using with signals. Let F1 of t and F2 of t are two signals. Whenever we are using the word of signal, the signal should be with respect to some time interval t1, t2. Signals continuous, that means for using integration. So here if integral t1 t2 of f1 of t multiplied by f2 of t dt is equal to 0, then this is called orthogonality principle in signals. Now just look at same orthogonality property with respect to vectors. Dot product of two vectors equal to 0, then it is orthogonal with respect to vectors. Now just look at here V1, here signal 1, here dot, here it is multiplication, here vector 2, but here second signal. This is direct open common dot product. It doesn't need any other operators, but here because of its continuous property we are integration, continuous signal. So integral from which one? From the time interval between t1 to t2 continuous. This is integral. So we are integrating with respect to which variable? T variable. If this is equal to 0, it is orthogonal. If this equal to 0, this is orthogonal. Now just look at, now here in this way, taking this concept and this concept, vectors and signals, these two are analogous on the basis of orthogonality. Therefore, orthogonality principle is very much important in this one. Orthogonality principle is very much important in this concept. So in the analogy of vectors and signals means students have to make it analogy. How can you make the similarity between vectors and signals on the only one basis, principle basis? That principle is called orthogonal principle. Orthogonal principle vectors, dot product of these two equal to 0. But here it is integral, this into this equal to 0. Just look at, both are same. Both are same. This same property that is called orthogonal principle. So now one more point, I am repeating the important point. The orthogonality principle is common to vectors and signals. That's why these two are compared to each other. So two signals are said to be orthogonal if signal F1 is a signal and F2 is a signal, and between the time interval T1, T2 with respect to variable t, if these two equal to 0, then the two signals are orthogonal. In examination they ask you, define how can you say that two signals are orthogonal, or when they will orthogonal? Signal f1, signal f2, product, multiply, make integral between t1, t2 with respect to t. If these two equal to 0, they are orthogonal. This is the orthogonal principle. This ends this session. Thank you.